My name's Paul Doe. I'm Chief Engineer of the Chassis Group at Prodrive Motorsport. My job is to lead my team to produce winning platforms that are capable of winning races around the world in different formats at the highest level. So in our industry, motorsport is obviously, by its very nature, incredibly competitive. And so we have to make sure that we are able to win, and not just win, but win profitably, which is an important point. You know, we don't have infinite budget. Prodrive is a commercial business, so we have to do things in the right way. Clearly, people is the key thing there. We have a very, very good team, particularly I'm very proud of my design team. Our team is fundamental to how we operate the projects, and we're outside of the design office as much as we are inside. The main issue we always have is actually time. Motorsport is a very fast-paced industry. We have to turn around complete car projects often in time of, let's say, 6 to 9 months, which is incredibly tight. So we have to make sure that we have all the right tools around us, be it scanning equipment, but the CAD, all sorts of other bits of technology, and that all fits together to enable our team to use their experience and their knowledge and their intelligence to come up with the best solutions as quickly and as efficiently as possible. I think since the introduction of the Scantech technologies into our workflow, we've seen that we do things really quite differently. One of the benefits of the Scantech technology is we're able to do a lot of verification during the build. So the P25 Subaru body shell that's behind me here was very intensive with scanning technology, because that was based on a road car that was built 25 years ago where the CAD data just isn't available. So being able to use scanning technology to be able to bring old data like that into our CAD system very, very quickly, which is the key thing there, enables us to have a high level of accuracy, a lot of data at our fingertips, but generally speaking, in a time frame that is incredible. And if there's new data that we need to gather because we find a new problem, we're able to bring that part out, get the equipment out, and within hours we're working with it live in our CAD database. Prior to our adoption of the Scantech technology, we'd probably be using more traditional methods like manual measurements, but also measuring arms, CMM in an inspection department for smaller components. And whilst that gets you an amount of information, obviously it's very limited. One of the benefits of the scanning system is we can have full visualization straight into our CAD in literally hours. One of the other benefits, of course, is how portable the system is. So we're able to take the equipment with us to a test, let's say, or a wind tunnel, and be able to scan directly there, bring the data immediately into our CAD and work with it. So that kind of portability of the systems and the flexibility of the systems is much greater, I think, than you would get with a traditional system. One of the benefits of working with T3DMC is we've got access to people who really know what they're doing in the world of metrology and scanning. We've got the kit, it's great, it's got massive potential, and we want to make sure we're using every last bit of that potential. We've had a great deal of on-site support, making sure we're getting, not just getting the best out of the equipment, but using it in exactly the right way for our needs. The software is quite intuitive and straightforward to use, but again, we need to know, are we doing it in the right way? The support has been pretty relentless by phone, by email. That's really helped us achieve what we need to do in a very short time frame. But one of the principal uses we've been using the Scantech equipment for is in the manufacturing of our Dakar frames. So these are steel space frames fabricated on site, very complicated products. About 1,000 parts go together to make a Dakar space frame. And you can imagine the amount of tooling that we could employ there could be massive and very, very high level of investment. One of the benefits of using the Scantech gear is we're able to scan it live during various assembly phases and check, are we getting the kind of results that we're looking for? Do we need to make any adaptations before it goes too far? We're probably saving a fortune in how we build the frames. But not only that, is we're able to turn them out very quickly and very repeatably. One of the areas that we're using the Scantech scanners for is our quality control. We are producing, on a good year, about 75 Aston Martin race cars out of this factory every year on behalf of Aston Martin Racing. We are scanning those full surface scans of those tubs, comparing them to the CAD model. Obviously, if we pick anything strange up, we can rectify that before the tubs reach car build. We're just embarking on a test program right now of 2 new vehicles, and we'll be scanning those tubs after a certain amount of track mileage, probably more than once, I think. Obviously, race cars are race cars. They do get crashed, not always at the fault of the driver, but sometimes it is. And those cars come back to us sometimes for checking to see whether the tubs can be, are they damaged? And if so, can they be repaired? All of that information is feeding into basically a digital twin of the car, and it's helping us a lot in understanding how we can best take the next steps to make better and better cars in the future. The reverse engineering is obviously a field that people are quite familiar with scanners. Since our adoption of the Scantech equipment, P25 Subaru, that was the first project that we did a significant amount of scanning and reverse engineering, with there being a lack of CAD data for that model available to us. I guess in the old days, we would be building that a lot more within the workshop environment. Using the Scantech equipment has basically enabled us to go back to our sort of standard type of engineering process that we would do with, let's say, the Aston Martins or the Dakar cars, which is to basically bring the entire vehicle into the CAD and enable the entire design team to work on a single model within the PLM software within our CAD environment, and treat it almost as if it was native OEM data. But to be able to commit to tooling prior to actually making the mock-up parts, and then when the parts come to the car, they fit. We were able to very quickly scan several cars, overlay them, see where the typical discrepancies were, and then make allowances for that into our design process for the parts. And I think, generally speaking, we consider that to be a big success. So in terms of prototyping, one of the areas that we'll be using the scanners for is helping with the prototype build of our new GT3 race car. This is all new bodywork compared to the previous generation, and we need to get that build right. The tolerances that we're required to have the bodywork fitted to is very, very small by regulation. I think plus or minus 1 mil in some areas. So we have to be very, very careful in the fitment of the bodywork. So as all the new panels come in out of the tooling, we'll be very, very carefully assembling those onto the tub and scanning each part as it goes on and making sure it's to the specification we need, obviously, and then we can react if we've got any problems. I think one of the benefits of having the two systems we have, the sim scan and the track scan, is we can use them for slightly different reasons, slightly different tasks. And I think we use both. A good example of that is we use both of them on our Dakar program, actually, because it's the toughest motorsport event in the world. 5,000k over more than 2 weeks across incredible terrain that would smash any normal car to bits. But what we need to do is monitor the health of our vehicles, and in particular the space frame. So being able to do large scale measurement with a track scanner and overlay the measurement results with historical data enables us to keep an eye on what's happening with the frame. Do we need to take any action? The sim scanner, of course, it being smaller and probably quite useful for other areas. We're able to get into wheel arches very quickly and check the status of that, which is obviously that's an area where you can pick up a lot of damage with rocks flying around in there and so on. So I think with both of those items in our armory, it's one of those things where we're just able to do things that we perhaps would have done in a more visual and basic manner before, but we're able to do it at such a higher level and actually very fast. Certainly from the experience we've had with the track scan and the sim scan and working with a 3D measurement company, absolutely no hesitation in recommending the kit, and in particular working directly with the engineers at T3DMC. They're the people who've unlocked the capability of the hardware for us and enabled us to find the solutions that we need. And I think the systems are so capable and widely applicable that I don't see why it wouldn't apply to anyone else in engineering.